Good morning, everyone. For our lesson for today, we will be talking about perfect square trinomial or PST. So going back to the steps on how to factor polynomials, always remember that the first step is to look for common factors among the terms of the polynomial. If there is, factor it out. For our second step, always look at the number of terms of the polynomial. So we have an option here that if ever it is a trinomial, you have two options, whether to use PST or quadratic trinomial. The question now is, if there are three terms or if it is a trinomial, how will you know that you should use perfect square trinomial or PST? So we have an example here on the left part of our screen. We are asked to find a product, we're provided with a given, and there is an answer. While on our right, we are asked to factor, and you should provide the answer. So notice that the answer in our left table is actually the given in our right table. So that means that the given in our left table is actually the answer of our right table. So the answer here is the quantity of a plus b times the quantity of a plus b, or the square of a plus b, because they're just the same, a minus b times the quantity of a minus b. And the last one, given is x squared plus 6x plus 9, so just the reverse of it, the quantity of x plus 3 times the quantity of x plus 3. I want you to pause this video and try to figure out the pattern, the similarities between the given, and figure out as well, how do we get the answer even if we're just given with 10 seconds? I hope you were able to figure out the pattern. For now, let's discuss what's the pattern on how do we determine whether it is factorable using PST. So first, they're all trinomial. Second, the first terms, these are all perfect squares. If you try to get its square root, what's the square root of a squared? That's an a. And the square root of an x squared is x. Let's jump to the third term. What do we notice about the third term? Yes, that's correct. These are all perfect squares. What is the square root of b squared? That's a b. What's the square root of a 9? That's a 3. Now, let's jump to the second term. If you notice, there is always a factor of 2. So that's 2, 2. With the 6, it also has a factor of 2. Because that's 2 times 3. Next, you will notice that it is actually the product of our first and second term when you get its square root. So for example, the square root of a squared is a. The square root of b squared is b. If you multiply a times b times 2, you'll get 2ab. Okay, did you get that? Let's try again in our third example. What's the square root of x squared? That's an x. What's the square root of the third term? That's a 3. So 2 times the square root of the first term times the square root of our third term, you will get 6x. So that's actually the pattern of PSD. The middle term or the second term is always an even number. So there must be a factor of 2. That's another way to determine whether it's factorable by PST or not. If it is not even, automatically you will not think of it as factorable using PST. There you go. That's how you will determine whether you can use PST or not. The first term must be a perfect square, the third term must be a perfect square as well, and the middle term is always even. It is actually a product of our first times the third term times 2. If ever you will now factor it out using PST, so always remember that it is a binomial. So there are two terms all the time in each of our factors. The next, so bino times bino. Now, the first term of our binomials is just the square root of our first term in the given. So the square root of a squared is a. Then the second term is just the square root of the third term, b squared. So that's b. Okay, let's try the third example. So that would be x because square root of x squared is x. Then the second terms, that's a 3 because the square root of 9 is 3. Now, what should be the operation in our binomials? That must be the sign, whatever is the sign of or the operation of our second term. So for 2ab, that's a plus beside it, before it. So you have to use plus here. So plus, then plus. Here, the operation before 2ab in the second term is minus. So you will be using minus as well. Here, before our 6x, that's a plus. So that's also a plus in here. That leads us to our generalization. Okay, let's remove the writings first. That gives us a generalization that when we use PST, the conditions must be satisfied. The first term must be a perfect square. The third term must be a perfect square. The middle term must be the product of 2 times the square root of the first term times the square root of the third term. And it doesn't matter whether the middle term before it is a plus or a minus. As long as the operation before our third term is always an addition. If that's the case, the shortcut to factor it out, always remember that it's binomial times binomial. The first terms is a square root of our first term in the given. The second term would be the square root of our third term in our given. And the operation depends on the sign or the operation before our second term in the given. So if it's a plus, then you use plus. Here it's minus, so you use minus in it. If you notice that two binomials are exactly the same, so we can actually write it in exponential notation by simply writing it as the square of a plus b. Because the two binomials here are exactly the same. Same here in our second. Both of them is a minus b. So you can write it as the square of a minus b. Now let us have an example. Let's determine first whether each trinomial is a perfect square or not. So we have here 4x squared plus 10x plus 25. The first term is 4x squared. The second term is 10x. The third term is 25. So notice that the first term is a perfect square because that's 2 times 2 times x times x. Or you can write it or think of it as 2x times 2x. So it's a perfect square. How about the third term? So check this sa first condition. The third condition is to make sure that the third term is also a perfect square. So 25 is 5 times 5, which is a perfect square. Now the second term, make sure that it is an even number. The numerical coefficient must be an even number, in which 10 is an even number. So you can factor out the 2 because it's necessarily necessary that there is a factor of 2 out from it. So if you factor out 2 from 10, you'll have 5. Then you have x. So if you get the square root of the first term, 4x squared, that would be 2x. The square root of 25 is 5. So if you notice, 2x times 5, then dapat may 2 din because that's a condition. 2 times the square root of first term times the square root of third term. So 2 times 2x is 4x times 5, that's 20x. So notice that in the second term, it's just 10x. So kulang. So automatically our answer is, it is not factorable by PST. Okay? So you have to be very careful in terms of deciding whether you will use PST or not. You have to take note of the conditions that you have to remember when you factor. Okay, let's have another example. Still, we are asked to determine whether each trinomial is a perfect square or not. 9y squared plus 60y minus 100. The first term here is 9y squared. The second term is 60y, and the third term is 100. Now, the first term is 9y squared, which is a perfect square because it's 3y times 3y. While the 100 is a perfect square as well. So that's 10 times 10. However, here's the problem. The problem is our third term, which is a minus. This is something na parang common sa mga students. So they will not take note of the operations. But take note the third term must always be a plus. Okay? So, ibig sabihin nito, automatically the answer is no. It's not factorable by PST because at the first place, the third term, the operation before it is a minus. It must be a plus. Kasi nga, di ba, if we would consider that as a sign for our third term, negative 100, negative 100 is not a perfect square. Not unless you factor out the negative. Okay? You cannot think of one number multiplied by itself, which it will result to negative 100. So, if you have negative 10, and if you multiply negative 10 by itself, that will become positive 100, not a negative 1. So the answer here is no. Let's try another example. The given here is 36w squared plus 60w plus 25. Our first term is 36w squared, in which you can factor it as 6w times 6w. So it is a perfect square. How about our third term? Third term is 25. Factor of 25 is 5 times 5. So it's still a perfect square. It's a plus, so that means it's okay. How about the second term? The second term must be the product of 2 times the square root of 36w squared, which is 6w, times the square root of the third term, which is 5. So 2 times 6 times 5, times 5, 2 times 6 is 12, 12 times 5 is 60. Then you still have the w, so 60w, in which the second term is 60w. So therefore, it is factorable by PST. Now we're ready to factor. So don't forget, always check first whether the conditions would fit into the given for PST. So for A, we have x squared plus 6x plus 9. First term is x squared. That's a perfect square. Third term is 9, which is also a perfect square. It's a plus, so it's okay. Then the middle term must be the product of 2 times the square root of the first term, x squared, which is x, times the square root of the third term, which is 3. So 2 times x times 3 is 6x. So automatically, it's factorable by PST. So x squared plus 6x plus 9, the expected result is there would be two binomials. The first term of each binomial would be the square root of the first term in our given. That's an x. While the second term of each binomial, it's a square root of the third term. Square root of 9 is 3. Then, copy the sign of our second term, the operation before it, which is plus. Or you can write your answer as the square of x plus 3. Let's have example number 2b. 9a squared minus 30ab plus 25b squared. So there are three terms. Always remember to check first whether the first and the third term are perfect square. First term, that would be 3a times 3a. Second term is 5b times 5b. And our expectation in our second term, it must be the product of 2 times the square root of the first term, 3a, times the square root of the third term, 5b. So 2 times 3, 6, 6 times 5, 30. Then a times b, ab, so 30ab. So therefore, you can factor it out using PST. So to factor, it is expected that there are two binomials. The first term would be the square root of the first term, so 3a. The second terms would be the square root of the third term, 5b. Then, copy the sign of the operation before our second term, minus. So you can write your answer as the square of 3a minus 5b. Okay, how about in C? How do we factor this out? So there are three terms. So take note. If you're thinking of verifying whether you can use PSD or not, the answer is a no. Obviously, it's not because of the 2. 2 is not a perfect square. So what could be our conclusion? Is it not factorable anymore? Okay, don't forget there's a first step. We have first step in which we have to figure out if there is a GCF in all our terms. So notice that in terms of numerical coefficient, they have a common factor, which is 2. Yung 2 natin, that's 2 times 1. 8 is 2 times 2 times 2. Yung pangatlo natin na term, 2 times 2 times 2 din. And then, we have a common factor, which is 2. So the GCF here is 2. So you have to factor out the 2. If you factor out the 2, okay, 2x squared divided by 2, what will be left is just x squared. In our 8x second term, divide by 2, because we already factor out the 2, so what will be left is just 4x. And lastly, the 8 in our third term, 8 divided by 2 is 4. Now, let's proceed to the second step. How many terms do we have left? There are 3 terms. So automatically, you can think of PST, but verify first whether it's factorable by PST or not. The first term, x squared, is a perfect square because that's x times x. The third term is a perfect square as well because that's 2 times 2. Our second term, always remember, it must be 2 times the square root of the first term, which is x, times the square root of the third term. Square root of 4 is 2. So 2x times 2, 4x. So there you go. So it's factorable by PST. So if you factor it using PST, there are two binomials. First term would be the square root of the first term in our given. Second term would be the square root of the third term. Square root of 4 is 2. We copy the sign for the operation before our second term, which is plus. So you can write your final answer as 2 times the square of x plus 2. And that's our final answer. For our next lesson, we will now discuss general quadratic trinomial. So you will be using this factoring technique if the given polynomial is a trinomial, but it is not factorable using PST. So kindly watch the next video. Thank you so much.